Hello everyone, my name is Jackson Ayeko, and for this project I decided to do predicting hospital readmission rates. You may wonder, so why do we have to care about hospital readmissions? Uh, One of the biggest problems for hospital readmissions goes to the patients. It costs patients a lot of money to be readmitted back into the hospital for a certain condition that they've been treated for. The second reason why we need to care, it's a financial burden for hospitals, especially for the new system that's being used, which is called the value-based reimbursement environment. The other reason is payers like Medicare and health insurance spend a lot of money to fund any hospital readmissions that happens within 30 days of discharge. According to a research I found, it's estimated about 26 billion is spent annually on hospital readmissions, and out of this 26 billion, 17 billion of these costs could be avoided. In 2017, about 2,500 hospitals were penalized for excessive hospital readmissions, and all these hospitals incurred an amount of 564 million were paid in fines by these hospitals. Medicare is not the only payer pressuring hospitals and providers to lower their hospital readmissions. In 2017, private insurers spent about $8.1 billion in hospital readmission, and Medicaid spent about 7.6 billion on hospital readmission cases. As you can see, these numbers are extremely large, and the insurance and any kind of payers are trying to lower the value of money they spend on hospital readmission, especially for cases that could be avoided. So 6 conditions are defined and covered under the hospital readmission reduction program. And these conditions are chronic lung diseases, heart attacks, hip and knee replacement, COPD, pneumonia, and acute myocardial infarction. So for this project, uh, my method of choice was deep planning, and I'm going to do my analysis in Python. So I obtained my data from healthcaredata.gov. So my initial plan was to do analysis on all the 6 conditions. Then when I loaded my data, I realized that the data was too large and I might not be able to obtain helpful information from the data. But then after I loaded the data, did some analysis and some cleaning, I realized that after I removed all the missing values, my data ended up being very small, so I ended up just running the entire project on all the 6 conditions, but the initial plan was to run COPD only. So for my data structure, like I said earlier, I obtained my data from healthcare.gov, and the data was presented as a data frame, and it contained 19,645 rows and 12 columns. And so here's an example of what the dataset looked like. So the dataset contained facility names, facility IDs, the state in which the facilities are located, and the measure name is what defines the 6 conditions, which will be COPD, acute myocardial infarction, and all the other conditions. And we also have a section that covers the number of discharges, another section that covers the excess ratio readmission, and then there's a section that covers the predicted readmission rate and expected readmission rate, number of readmissions, and then the start date and the end date of the project. So for my project, I decided to predict the number of readmissions, which I was going to use as to show me like the number of patients that were admitted. So I was trying to find a way to calculate those numbers before I actually get the actual number that were patients that were readmitted. So I did some exploratory data analysis, and the dataset contained a lot of missing values. So I did some cleaning and my data ended up being very small, like I mentioned earlier. So I ended up doing analysis on all the 6 conditions and predicted for all of them. But initially I was just going to work on COPD, but since the data ended up being really small, I decided just to run everything together to increase my analysis performance. So before I build my model, I did some preparation for the data. My initial approach was to remove all the missing values from the datasets because that would have impacted the analysis negatively, and I was trying to get the best analysis possible, so I removed all the missing values. The second thing I did was to remove all the sections of the datasets that I felt would not impact my analysis in any way. So I removed the dates from when they counted the 30 days since when the patients was admitted to when they were discharged. I removed like the facility names, facility IDs. I was just trying to remain with the columns and sections that were going to impact my analysis, so that's why I ended up removing that section. And then the next step was to split the data into training and test data and removing the section of interest from the data set. So I did a 80% training and 20% test for my data set. And since I was going to predict the number of patients readmitted in the hospital, I removed that from the dataset to try to train my system to predict and compare those numbers to the actual numbers that were readmitted to the hospital. So I built a neural network using a sequential model, and I use the activation model ReLU, which is rectified linear unit. And the next thing I did is compilation of my data using optimizer Adam, and my matrix was the mean absolute error. I used the mean absolute error to calculate the performance of my model, and I used 500 epochs to do the analysis, and sample size for my batch was 100. A little bit about epochs was, so epochs are basically the number of times that you have your system do the analysis on the set number of samples that you want. So for this example, I'm using a batch of 100 samples. So from my dataset, the system will pull 100 sample and run through those samples 500 times, and then compare it to use that to build the model for the results. So after building my model, I plotted the values of the training and the validation loss just to compare and see how my model performed compared to the actual values of the patients that were readmitted to the hospital. So this is the plot of the values that I obtained, and on the y-axis of the plot you can see is the loss, and the x-axis is the epochs, the number of times that the analysis was run for each batch. From this plot, if you understand what neural networks, how neural network works, this plot is actually terrible, and this is just an indication that the model did not perform very well. In the next slide, I have a plot of what the results was expected to be. This what something like this was expected to look. This is what it was expected to look like. So you basically have on the left the number of losses. You're trying to minimize the number of losses every time you increase the number of epochs. So the higher the number of epochs, the lower the number of losses you're supposed to have. So the losses are actually the comparison between the calculated value and the actual value. So you're trying to lower the difference between those two, and as you can see, the lower the epochs, then the higher the value of the loss. And if I go back to the previous slide, sorry, went forward, but anyway, if I go back to the previous slide, you can see my values were actually not approaching each other, but they were decreasing. So it was showing some signs of positive performance, but it was actually decreasing compared to what we were expecting. So my mean absolute error was 6.95%, and the loss was 51%. And as I mentioned earlier, this did not perform very well, and normally you want to get a mean absolute error of less than 1. That's actually an indication that your model is performing real well, but this is extremely high. So I can just tell the model did not perform very well. And in conclusion, my analysis was not much of a success, and this was because the mean absolute error was too big compared to what I was expected. I tried to modify the number of epochs to see if I can lower their mean absolute error, but it wasn't changing very much. So I concluded that this large mean absolute error was attributed to the small dataset used. Like I mentioned earlier, when I cleaned up the data and removed all the missing values, the dataset ended up being extremely small, and neural networks require a big number of data sets so the neurons can learn and do a better prediction on the analysis that you're trying to achieve. And that was the end of my analysis, and thank you everybody for listening.